This is a moment's question about tilting. We have a uniform plank that weighs 1200 newtons. So uniform means that the weight force acts right in the middle of the plank. So we can represent that on our diagram. We can see that our plank has a total length of, if you add all those three things up, 3.4 meters. So if we were to do 3.4 meters divided by 2, that gives us 1.7 meters. And that would be the place where the weight of the plank acts from. So over here, let's say, that's 1200 newtons. And this distance here is 1.7 meters. And we're told that the plank is resting on two pillars in the question. And in these two sentences here, we're given the distance between the supports and the ends. We're told the weight of the man. The man weighs 800 newtons. And he walks along the plank away from pillar P, so he walks towards the right. Let's draw on the weight of the man. The question asks, what is the horizontal distance between pillar P and the center of mass of the man when the plank starts to tip? So, where the man is standing right now, the plank won't tip. Because he is in between these two supports, here and here, the plank won't tip. But then, as soon as he passes point Q, so let's say he gets to like this point over here, then the plank might start to tip. So if we're at the point when the plank is just about to start tipping, then what that would mean is the plank is basically balancing finally on this point Q here. It's just teetering on pillar Q. If that's the case, there is no reaction force at pillar P. The reaction force here would be 0. It's just balancing on pillar Q. So all of the reaction force will be therefore at pillar Q. I want to rub out the weight force of the man over here. We're forgetting about the man being there. The man is now over here somewhere. So that is the 800 Newton force. We have some contact force at Q, which I'll just call R. So this will be the force diagram when the pillar is on the point of tilting about Q. If the man moves any further towards the right, then the plank will tilt. In the position where the man is standing right now, the plank is just finally balancing on Q, and the normal contact force at P is 0. So we're trying to work out the distance between P and the man. So we're trying to work out what this distance here is. So one way that we can solve this question would be to take moments about point Q. Let's call this distance here x. So if we're taking moments about point Q, first of all, R has no moment because it acts through Q. It has no turning effect. The distance on the left-hand side of Q between 1200 and point Q, well, if we look at this is 2 meters. We have this distance is 1.7 meters. The difference is therefore 0.3. So here is 0.3 meters. And then we can multiply the force by distance for the 800 Newton force. So it'll be 800 multiplied by x. That's the clockwise moment due to the 800 Newton force. I know it's clockwise because if we start where the force acts, follow along the direction of the force and then go around the pivot, that gives me a clockwise direction. And similarly for the 1200 Newton force, start from where the force acts, follow along the vector, go around the pivot. Remember that Q is the pivot. And that direction that I've drawn there is anti-clockwise. So clockwise moment, 800 times x is equal to anti-clockwise moment, 1200 times 0.3. So then 800x is equal to 360. And then divide both sides by 800. That is 0.45. So we're trying to find out the distance from P. We now know that x is equal to 0.45 meters. So then the distance from P all the way to the weight force will be 1.8 meters plus x. So 1.8 plus 0.45, and 1.8 plus 0.45 would be 2.25.